Today we will be doing section 6.1 in your book. First, I would like to explain the vocabulary word diagonal to you. A diagonal of a polygon is simply a segment that connects two non-consecutive vertices. For example, if I choose vertex P, PS and PR are diagonals coming from vertex P. PQ and PT are not diagonals because Q and T are vertices right next to vertex P. Another example would be diagonals coming from vertex Q. QT is a diagonal coming from vertex Q, and so is QS. Again, QP is a side of that polygon and not a diagonal, as well as QR is a side and not a diagonal, because P and R are right next to Q. Since T and S are not right next to Q, the segments that connect Q and T and Q and S are diagonals. This particular polygon has two diagonals coming from each vertex. Another diagonal from vertex R will go to RT. These are the two diagonals coming from vertex S, and another diagonal coming from vertex T would be TR. Now I would like you to do this activity. You're going to be drawing convex polygons with different numbers of sides in Sketchpad. You are only going to draw the diagonals from one vertex, so I'd like to demonstrate that for you. I'm going to make a random polygon. Again, make sure your polygons are convex, where all the sides are pointing out, instead of concave, where one or more of the vertices is pointing in. Okay, now I'm going to draw diagonals from one vertex. First one, I'm going to choose vertex A. I'm going to skip points F and point B since they are right next to A and draw diagonal AE, diagonal AD, and diagonal AC. Do not draw any other diagonals in this picture, as these are all the diagonals that come from this one vertex. Then, once I've drawn the diagonals for that polygon, I'm going to answer the questions in this chart. This was a six-sided polygon. So in the chart I would go to 6 sides. I would see that I have 4 triangles here. So here I would say that the number of triangles is 4. Then, knowing that the angles in a triangle add up to 180 and I have 4 triangles, I'm going to put what the sum of the angles would be using those triangles here. Then I'm going to check my answer using Sketchpad. So I'll go ahead and measure all the angles of this particular polygon. Notice I'm only measuring the interior angles of this polygon and not the angles made by the diagonals. Okay, now that I've got my 6 angles, I'm going to go ahead and add them up. And this is the sum of all the interior angles using Sketchpad. Check to see, do these match? And is this a good method for figuring out the sum of all the interior angles in different polygons? Once you think you have a pattern established between the number of sides in a triangle, the number of triangles that it makes, and the sum of the interior angles, go ahead and fill out this last section here. Okay, Now that you know about how to find the sum of the interior angles of any convex polygon, we're going to look at the sum of the exterior angles of any polygon, convex polygon. I'm going to go ahead and open this link, and I have here a 5-sided convex polygon, or pentagon, and I'm going to use the dilate arrow to move this polygon back and forth. When I dilate a polygon, it changes size, but the angle measures stay the same. So in this particular polygon, the interior angle measures and the exterior angle measures are the same no matter how big or how small I make this polygon. So I want you to watch what happens with my exterior angles as I make this polygon smaller and smaller and smaller, and finally I make it a single dot. What do all of these angles, these exterior angles of that polygon, add up to? Think about going around in a circle.